Hi, my name is John Krockmalny, and I've created this tutorial as an instruction for anyone wanting to learn how to configure an analog multimeter and take measurements. It is very important to understand that electrical energy can be fatal or cause serious injury. This being said, do not touch exposed live electrical circuits and related components. Always handle the multimeter and related leads by their plastic non-conductive frames and not by the metallic portions. When working on live and exposed electrical circuits and components, always wear the correct personal protection equipment specified for that particular job, as outlined by the National Fire Protection Association NFPA 70E standard for electrical safety in the workplace. There will be two learning outcomes related to this presentation. Number one, configure analog multimeters to measure voltage and resistance. And then number two, read the analog multimeter electrical values. Here is a graphic of an analog multimeter used in this presentation. There are other manufacturers of analog meters that may look different, but the configuration and utilization will be relatively the same. Analog multimeters are different than digital in that there is a needle indicator that travels the distance of a meter scale. This meter position corresponds to the value printed on the scale. The term parallax concerns how one sees the needle position of the meter to the background scale. Parallax is the apparent shift in the position of an object when viewed from different locations. Configuring the multimeter to measure electrical values consists of 4 steps. Number 1, consider what it is to be measured. Number 2, set the multimeter leads. Number 3, set the multimeter selector switch to read that value. And number 4, take the measurement. Let's consider what it is we want to measure. We'll start out with measuring for voltage with this analog multimeter. Step number 2 tells us to set the multimeter leads into their proper positions. In this meter, the black lead will always be placed into the COM or COM port of the meter. The red lead will be placed into the port indicated by the V, omega, and A port. Step number 3 tells us to set the multimeter selector switch. In this case, we'll set it to read voltage. In this meter, we see marked in red lettering ACV for alternating current voltage. Notice that I have several scales in which to choose from. If we wanted to measure for direct current voltage, notice that this scale is located to the left of the meter. Let's anticipate measuring for voltage of no more than 10 volts. If that scale is selected, whatever values are measured will correspond to the 0 to 10 scale on the display. If the selector switch is moved to read up to and including 250 volts AC, then the scale of between 0 and 250 is referenced. We may use the same analogy when selecting voltage DC values. Selecting the 2.5 scale on the DC voltage scale, it will reference the scale marked between 0 and 250. When recording this value, make sure the decimal point is recorded accurately. Important: the voltage measurement represents a danger to personal safety if not performed properly. Do not touch live and exposed electrical parts and terminals. Step 4 says then to take the measurement. Notice on this graphic that the metal portions of the meter leads are inserted into live electrical circuits. The leads of a properly configured multimeter set for voltage can measure both the applied voltage of the electrical circuit source and the voltage dropped across the circuit load, in this case the LT-1 green lamp. Now, Let's consider how to configure the analog multimeter to read resistance. Starting with step number 2, we set the multimeter leads. In this meter, the black lead is placed into the common port, and the red lead is placed into the V, omega, and A port. Step number 3 tells us to move the meter selector switch to read resistance, or ohms, as displayed. Notice on this graphic that there are several ohms scales to select from. Each setting will instruct the user on using a multiplier to the measured value. Only with the analog multimeter configured for resistance or ohms will have an adjustment for zeroing out the needle indicator. Notice on this graphic that the ohms resistance scale is located at the top of the display and only pertains to the resistance measurement. To the left of the scale, you'll notice that there is an infinity symbol or infinite resistance. Another way in which we can look at this is that it represents the open line of the circuit. To the right of the scale, you'll notice that there is a 0 indicating no resistance. For analog meters configured to read resistance, an additional step has to be performed before taking the measurement. It's called zeroing out the meter. This is where the leads are touching each other and reading the scale. Notice in this graphic that there is a pegging of the meter beyond the 0 scale mark. The adjustment wheel is moved to where the display needle points to the 0 on the scale. After the multimeter is configured for resistance, or ohms measure, we can now take the measurement. Note, when using a multimeter configured to read resistance or ohms, the component to be measured must not be connected to any power source. In this graphic, notice that the R1 load is removed from the power and then the resistance configured meter placed across the components being measured. Taking the measurement for resistance involves relating the position of the meter's needle to the scale. In this example, and with the meter to read Rx1, the needle point is the value of 1, and with a multiplier of 1, the measured value is going to be 1 ohm. Staying on the Rx1 selection, we see that the measured value of 50. 50 times the multiplier of 1 equals a value of 50 ohms. On this graphic, the switch is set to read Rx100, or whatever value is displayed will be multiplied by 100. In this case, the needle points to 10 and multiplied by 100. The measured value will be 1,000 ohms. Here, we see a measured value of 20,000 ohms of resistance. To sum up this presentation, analog meters have a needle that moves across the scale. This scale has numbers that show actual values based upon the needle's actual position. The read values could also be an error because of the parallax of the viewer. And configuring the analog multimeter consists of 4 steps. Number 1, consider what it is to be measured. Number 2, set the multimeter leads. Number 3, set the multimeter selector switch. And then number 4, take the measurement.